So let us discuss one more solution. Problem set 3.1, solution to 3.5, parallel forces and couples. This time we have a locomotive pulling a train. Now this is the locomotive. These are the wheels shown here. Now this is the track. This is the track, the rails on which it will be pulling the bogies behind it towards right with a force P. Now what we have to assume that these center points, the center of this wheel and the center of this wheel are very close to the surface. Owing to the weight W of the locomotive has a weight W acting vertically downward. The reactions are 2 points of contact here and here. Reaction here is shown as RA, reaction here is shown as RB in the original diagram. Each equal to be W by 2. When the locomotive is pulling the train, this is the compartments of the train are to this side, so it is pulling to this side, and the compartments are joined with the locomotive by a drawbar, a mechanism that connects the locomotive and the load that it is pulling. Pull P is just equal to the total friction at the points of contact A and B. This P is just equal to the force of friction here and here, means it is moving with a constant velocity. Determine the magnitude of the vertical reactions RA and RB. So let mu is the coefficient of friction between the wheels and the rail on which it is moving forward. So since it is moving to this side, the force of friction here and here will be backward. It will be mu times the normal reaction. Now let us balance the forces along y-axis. Now reaction RA, reaction RB at point of contact A and B are pointing to this side. W is opposite to that. So for equilibrium, RA plus RB will be equal to W. Now what you have to assume here is the points A and B are very close to the ground, Why I have considered close to the ground, I'll explain you here. And now the reaction at B does not produce any moment about point B because the line of action of this reaction force RB passes through the same point, means it is neither passing this way nor this way, means this does not have a perpendicular distance from the point B, so this does not produce a moment about point B. Now let us take the sum of the moments about point B, means the clockwise movements and the anti-clockwise movements. Now if this W is exactly in between, so from this point to this point and this point to this point are equal, I have taken it as A and A. So the reaction force RA here is at this perpendicular distance, that is 2A from point B. So RA times 2A is a clockwise movement, and the line of action of P, that is this line, since B and A are very close to the surface here, so the line of action of P is at this perpendicular distance, that is given as B. So P times B will also produce a turning effect about point capital B, that is also clockwise. So RA times 2A plus P times B, both are clockwise movements, and that is to be balanced by an anti-clockwise movement. And which one is producing that anti-clockwise movement? Anti-clockwise movement, look, W times this distance. W times A will be a anti-clockwise movement. RA times this distance is a clockwise movement. P times this distance. This is the reason why I have considered A and B are very close to. So both the moments are equal. For equilibrium, they must be equal and opposite. So take 2a, take p times b to this side, it will be subtracted, that is pb. 2a was multiplied, is divided, ra. Now, so wa by 2a minus pb by 2a. So a cancels, w over 2 minus pb over 2a is your reaction force at A. Now put this value of Ra in equation 1 here to find out Rb. So Rb from equation 1 will be W minus Ra. Now for Ra I substitute this minus W by 2 minus of minus plus this. W minus W by 2 is W by 2 plus PB by 2. So your RB is equal to W by 2 plus PB by 2. So that is all about. I hope it is clear to you. Now, why I have considered these 2 points very close to each other? If I don't consider, then this force will also have a turning effect moment about this point. Since B is very close to the surface, the line of action of this doesn't have a perpendicular distance from B. Similarly, the line of action of this mu times RB, since V is very close to this, also does not have a turning effect about point B. There is no moment. So I have taken therefore A and B are very close to the surface. So it is clear to you. Thank you.